Identification and quantification of impurities is of great concern because most of them are toxic in nature and pose threat to the life of human being. Impurities does not add any therapeutic value or benefit, and hence they are not really a need or the requirement, and hence all impurities present into the APIs or pharmaceutical products must be controlled as much as low possible. And in today's video, we are going to discuss about how one can set the limit for unknown impurity or for the known impurities. Now, if you look at the ICH guideline Q3A-R2 and Q3B-R2, which deals with the impurities into the new drug substances and new drug products. So in this ICH guideline, you will find three important thresholds. One is a reporting threshold, second one is identification threshold, and third one is qualification threshold. So what is the significance of these three thresholds as per as the control of impurities? And this is the talk of the today's presentation. So let me open up the presentation about the how these three important thresholds guide us in controlling the impurities, maybe into new drug substances or into new drug product. So in given case, I am going to explain you how one can use the ICH guideline Q3BR2, which is for impurities into new drug products to control the impurities. And here is the first threshold, which is the reporting threshold. So what is meant by a reporting threshold? So the reporting threshold is the threshold above which the impurity must be reported. And the reporting threshold always depends on the maximum daily dose. The maximum daily dose of the drug product that you are discussing. So in case if you are conducting a stability study or maybe a routine analysis, and if you found that the impurities are crossing the limit of reporting threshold, and let us understand what are the reporting thresholds as per as the uh, impurities are concerned or drug product is concerned. So in case if the maximum daily dose is less than 1 gram per day, then the reporting threshold is 0.1%. So what this indicates? So in case if you found the impurity is above 0.1% now, then you must report that impurity maybe during routine analysis or maybe during stability study. So this sets the disregard limit. So below 0.1% now the impurities can be disregarded. But the moment the impurities are found above 0.1%, then you must start reporting them. So this is how the reporting threshold guides us on reporting the impurities. And in case if the maximum daily dose is greater than 1 gram per day, then the reporting threshold becomes how much? 0.05%. Now there is one more interesting connection between a reporting threshold and the LOQ. And let me explain you what is that connectivity. Now as I said that the above reporting threshold impurities must be reported. Now to report the impurities precisely and accurately, we must understand that our method's LOQ must be at least equal to the reporting threshold, or if not, then below the reporting threshold. But it must not be, it never should be above reporting threshold. For example, if our reporting threshold is 0.05%, just in case if the maximum daily dose is greater than 1 gram per day, so our LOQ value of the related substances method for that specific impurity should not be greater than 0.05%. So for example, if the LOQ value is 0.07% with the reporting threshold of 0.05%, in that case, your LOQ will not be accepted. But if your LOQ of the method is 0.03% for that specific impurity, then of course your LOQ will be accepted. So the reporting threshold also guides us on to the methods LOQ requirement. The second important threshold is the identification threshold, and here is the definition. The impurity above identification threshold shall be identified. Now we understand that above 0.05%, for example, the impurities needs to be reported. Now these impurities are unknown to us. We do not know the structure of those impurities, but how far these impurities can be kept as an unknown impurities. How long we can report them as an unknown impurities. And that limit is called as the identification threshold. So as long as these impurities does not cross the identification threshold, we can report them as an unknown impurities. So in another word, the identification threshold defines the limit for unknown impurities. Below that threshold, I can live with the impurity as an unknown impurity. And hence, the identification threshold guides us, provides a guidance onto the limit for unknown impurities. And the basis is again the maximum daily dose. So let us understand now what are the different limits for the drug products in case of identification threshold. And if the maximum daily dose is less than 1 milligram per day, if it is less than 1 milligram per day, then here is the limit now. 1% or 5 microgram total daily intake. TDI stands for total daily intake, whichever is lower. Now in case of reporting threshold, we saw that the limit was given in terms of only percent, either 0.1% in case of less than 1 gram per day maximum daily dose, or 0.05% in case if the maximum daily dose is greater than 1 gram. But now look at here. In case of identification threshold, if your maximum daily dose is less than 1 milligram, the limit is how much? 1% or 5 microgram total daily intake, whichever is lower. So we need to understand whether 1% is lower or 5 microgram of the total daily intake of that specific impurity is a lower, and whichever is a lower will become the limit for the impurity. And would you like to understand with the help of very simple example? And here we go with the example now. So the maximum daily dose is 0.4 milligram. Look at the example over here. How much is the maximum daily dose? It is 0.4 milligram. So first convert this 0.4 milligram into a microgram. And why microgram conversion is required? Because if you read this, the limit it is 5 microgram total daily intake. So to have apple to apple comparison, convert this milligram dose into a microgram, and then you will understand that now 0.4 milligram is equal to nothing but 400 microgram. And then consider the maximum daily dose as your 100%. So the 400 microgram will become your 100%. So convert this microgram term into a percent term now. So 5 microgram is equal to how much percent? Let us assume it is x%, and then you will understand now this x is equal to 1.25%. So the 5 microgram with respect to 0.4 mg of maximum daily dose will become 1.25%. Now what is the equation available? 1% or 5 microgram, whichever is lower. So which one is lower? Whether 1% is lower or 5 microgram, which is nothing but 1.25%, which one is lower? So you can easily understand that it is the 1% which is lower and not the 5 microgram, and hence the 1% will become what? The 1% will become the limit for your unknown impurity, because we are talking about the identification threshold. So your unknown impurities limit is now not more than 1%. So do you got how one can establish the limit for unknown impurity just by understanding the identification threshold? Yes. And then similarly, in case of 1 milligram to 10 milligram per day maximum daily dose, the 0.5% or 20 microgram TDI, whichever is lower. Similarly, in case of 10 milligram to 2 gram, the limit for unknown impurity will be either 0.2% or 2 milligram TDI, whichever is lower. Then greater than 2 gram, the 0.1% is the limit for unknown impurities. So this is the way identification threshold guides us on evaluating the limit for unknown impurities. Would you like to know how to understand or how to evaluate the limit for known impurities? And for that, we must understand the qualification threshold. And here is the third threshold, which is the qualification threshold. And here is the definition. The qualification threshold is the impurity threshold above which the impurities needs to be qualified. So as long as your impurities are below the qualification threshold, you need not to qualify them. Now what is meant by impurity qualification? The moment impurity crosses the qualification threshold, then one has to prove the safety of impurities at that particular level. And it can be done with the help of toxicological study. But as long as your impurity levels are below qualification threshold, then you can live without qualifying that impurities. You need not to conduct any kind of safety studies. And then you will realize that the moment now we understand at certain level below which I need not to identify the impurities. But now as my impurity is crossing my identification threshold, I must identify impurities. What is the structure, molecular weight, and stuff like that. Now, the moment I identify the impurities, let us say it is the impurity A, I understand or identify that impurity as impurity A, for which I know the structure, I know the molecular weight. And then I found that the impurity A, which is known to me, is further increasing during the stability study. So how long these impurities cannot be qualified? How long I can live without qualifying the impurity? And that is just up to the qualification threshold. As long as my known impurity is not crossing the qualification threshold, I need not to worry about the impurities. And hence, the qualification threshold guides us, provides a guidance onto the limit for known impurities. Okay, and let us understand now how one can identify the limit for known impurities. Maximum daily dose must be known. And again, there are 4 different criteria from less than 10 milligram per day. And the limit for now, this is what? Limit for known impurities. Yes or no? And what is this? 1% or 50 microgram TDI, whichever is lower. And let me explain you with the help of very simple example that if the maximum daily dose is 9 milligram, right? So convert this 9 milligram into microgram, and we know the logic, right? So 9,000 microgram is equal to 100%. So what is the limit? Is 50 microgram. So 50 microgram is equal to X%, and you will realize that the value of 50 microgram in terms of percent with respect to 9 milligram is 0.56%. Now which one is lower? Whether 1% is lower or 50 microgram is lower. You can easily understand in this case now the 50 microgram is lower, because 50 microgram is equal to 0.56% with respect to the 9 milligram maximum the daily dose. And hence this 0.56%, yeah, this 0.56% become the limit for the known impurities and not the 1%. So do you got how to calculate and establish the limit for known impurities? Isn't it simple? Yeah, it is truly simple once you understand the fundamentals of setting and operating these reporting thresholds or identification thresholds or the qualification thresholds. Now, once we understand the reporting, identification, and qualification threshold, we are now well versed with the limits. What should be the limit for unknown impurity? What should be the limit for my known impurities? But is there any situation wherein the limit for known impurities can be different from the qualification threshold? Is there any possibility that even my qualification threshold is, let us say, 0.56% that we just saw in case of 9 milligram maximum daily dose, but you will ask to tighten the limit below 0.56%? Now, what are those circumstances during which you may have to lower the limit below qualification threshold? And here are the situations. The situation number one, if impurity is mutagenic. If impurity is mutagenic, then probably the qualification thresholds or the limit defined with the help of qualification threshold will never be applicable. And you have to govern the limit for those impurities with the help of ICH guideline number M7, which is dealing with the mutagenic impurities. And you have to identify then what is the threshold of toxicological concern, and then if it is 1.5 microgram per day, then set the limit accordingly. But you will not be able to leverage the limits provided with the help of the qualification threshold. The second important point is, let us say, if impurity belongs to a class of compound which have unusually potent toxicities. So, if the impurities is having the toxicological concerns, for example, the nitrosamine impurities, which is again the class of mutagenic impurities, but they are highly toxic. They are also called as the compounds belongs to the cohort of concern, very potent impurities. So these impurities again needs to be controlled according to the very specific guidelines and not through the qualification threshold. The third one is if compendial limits are lower than qualification threshold. If you have a compendial method for your product, and if you found that the same impurity A limit is very different from your qualification threshold, and it is found to be lower than qualification threshold, so there must be some safety issues with that impurity. That's the reason the compendial limit is lower, and you must follow the compendial limit in that case. If there is a immunological or other clinical concerns, so in these four different points, one has to consider the possibility of lower qualification threshold limits for the given impurities. Now let us also understand, is there any possibility to have the higher limit than the qualification threshold? If my qualification threshold for impurity is 1%, can I further relax the limit to not more than 2%? So yes, there are certain possibilities at which you will be able to leverage the higher limit for the given known impurity. And what are those considerations? And here are they. If toxicological data suggests higher limits, the very first point is what? You have proved the safety concerns of the impurity. You have carried out the toxicological study, and based on that you understand now, though the qualification threshold is not more than 1%, but my impurity is found to be safe at not more than 5%. So you can increase the limit in that case. The point number 2 is comparative impurity analysis of test versus reference or the reference listed drug product. Now in this case, you need to test the various number of batches of the test product, which is your in-house product, and then the reference listed drug product, the reference product for the impurities, and then understand if the RLD has got the higher level of impurity, that particular specific impurity, then based on this data, you can also increase the impurity limits at least up to the level found into the RLD. But to substitute this information, you must be very careful about the storage and the transportation of the RLD product, right? Because there must not be any evidence wherein the excursion outside the storage condition has happened. So the data logger is of utmost importance if you want to suggest higher impurity limits based on the comparative analysis. The third important point is if impurity is a significant metabolite. So if impurity is proved to be a metabolite, like in case of aspirin, salicylic acid is the active metabolite. And if you look at the USP monograph, you will find the limit of, I think, around 3% because it is a metabolite. And hence a higher impurity limits beyond qualification threshold is possible if you prove that the given impurity is a human metabolite. The fourth number is if higher compendial limit. If the compendial, if the method, the product is official, and if the compendial limit for the impurity is higher than the qualification threshold, then you will be able to leverage that limit and then move ahead. So these are the four different points at which the higher limits than qualification threshold is possible. Now you must be having a question in mind. I understand the setting the limit for individual impurity may be unknown, known. I understand now what are the circumstances, situations wherein the lower limit, uh, the impurities with the lower limit than qualification threshold is possible. I also understand at what circumstances the limit for impurity higher than qualification threshold can be set. But would you like to know how one can set the limit for total impurities? So here is the point how one can understand the limit for total impurities, and here are the guidances now. So one can set the limit for total impurities based on what? The summation of specified, identified and unidentified individual impurity. So in case if you have a specification in hand and in your specification talks about the identified or the known impurities, which are specified known impurities, and then there are certain specified unknown impurities. So based on the summation of these individual impurities, you will be able to set the limit for total impurities. The point number 2 is, and let me show you with the example now, then we will move on to point number 2. So the impurity A limit is not more than 0.5%, impurity B limit is not more than 0.3%. Just look at the screen here. The impurity at RRT 0.96. This is called as the specified unknown impurities, right? It is 0.2%, and then the total impurity is calculated by just summing all these impurities and come to a figure of 1.0%. Now let us understand what is the point number 2 in setting up the total impurity limits. So the total impurity limit should be set and it should not exceed the threshold that may compromise product potency or the assay. In point number 1, we talked about summation of all these specified known and unknown impurities, provided that summation must not compromise the assay or potency of the drug product. Now, if the summation of impurities comes to be 10%, and if my assay limit is, let us say, 95 to 105%, will this approach acceptable? It will not. And let me help you in proving with the help of very simple example. Yeah. So this is the first example that we just talked, right? That 1% was acceptable and we happily agreed to that point. Let us understand now the second example. And what is the second example? So impurity A is 0.5, B is 0.3, C is 1%, D is 0.3, E is 1.5%, F is 0.3%, and impurity at RRT 0.96 is 0.2%. So summation of all these impurities together comes to be 4.1%, and our assay limit is 95 to 1.5%. So in that case, is it really holistic approach if one can say that okay, now 4.1% is my total impurity limit? It will not, and hence that's the reason this information needs to be used holistically and to understanding how the total impurity limits is not going to compromise onto my potency of the drug product. So maybe 4.1 could not be a good figure, but we can understand and put the limit of, let us say, not more than 2.5% as a limit for total impurities. So it is not acceptable in the second case. And of course, in first case, where the total impurities summation found to be 1%, it must be unacceptable. So this is how one can control the impurities into the drug products. Now I presented the topic on the drug product, but a similar approach can be also used in setting the limits and controlling the impurities into the drug substance or API. So I hope you must have got an overview on how one can control, identify the impurities. It may be unknown, known, or even total impurities. And what are the situations wherein the limits below qualification threshold will be applicable, and what are the circumstances wherein you can set the higher limits, above the qualification threshold. So thank you very much for watching this video till the end, and I will meet you soon in another such kind of interesting video. Till then, thank you very much and take care. Bye bye.